recording. So same thing as before, like if you guys want that free meal, hey, low haul 415. Y'all know that pantry was today, right? So it's also tomorrow too, right? So if you guys didn't sign up yesterday, sign up and then go get your groceries, all right? I believe, don't quote me on this now. I believe that they close at 5 p.m. on Wednesday and then 6:30 on Thursdays, right? At least that's what it was in the school semester, but right now it's summer, so things might have changed. So just speak with them before anything. The same people that's giving you that free meal every day, right, are the same people that run the pantry. So you could ask them the question, like, what time is it and stuff like that. You know, take advantage. It's free. Once again, if you're gonna pick up meat from them, just know that it is rock solid frozen. Like you don't got to worry about it, like thawing out by the time you get home and stuff. You'll get home in time and all that. All right. Um, that's about it. Anybody have any questions? Huh? So which one you're asking about? They're in two different locations. So the groceries in Low Hall. I don't know the room number. What I could tell you is go into Low Hall and then make a left. When you make a left, it's right over there. When you walk in, like up the stairs or whatever, and then just left, and you'll see it. Like there'll be like some people sitting outside. That's the pantry, right? Um, for the meals, it's in Low Hall, room 415. Right? So pantry is Nichols Hall, and the food is Low Hall on the fourth floor. Yeah. So yeah, take advantage. You know? All right. Um, I literally just sent y'all all a message. Did y'all get it on Brightspace? Y'all could confirm with me that y'all got it. You got it? All right. Cool, cool. Huh? Go to Brightspace. Log into Brightspace. You logged in? So you should see it in the announcements. No? Yeah. 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 Week two update. That's it. That's the one. Yeah. So in there, I got the recordings from earlier this week. Got your link for the homework, in case you don't have it. I got you with the link for tutoring in case you want to make an appointment to go to tutoring. They like when you make an appointment, but if it's last minute and you can't help it, you can just walk in as well. All right? No, no problem with that. All right. So since y'all got the announcement, does anybody have any questions you guys would like to go over? Any homework questions, anything? Yeah. So what's happening, right? You have two functions. Hold on. Let's say I have f of x is equal to 2x plus 3. I'm just making this up, right? And I want to know what is f of x minus, hold on. What happened? Okay, sorry about that. Gotta change this. Let's see. All right, minus f of 2, for example. Just making this up, right? So the f of x is literally just this function you see up here, right? So that's going to be the 2x in parentheses, right? Because I'm going to distribute the negative onto it, right? Or the minus sign. So that's what's happening here. So this is going to be 2 times 2 plus 3, right? Hold on. What's going on here? Give me 1 second. Hold on. What's going on here? You still see okay? Sorry, I just had like a little pop-up on my screen. Sorry about that. Let me try that again. So this would be 2 times 2 plus 3, right? Because these are numbers, you could just deal with the numbers, simplify it on the inside, and you're just minusing out one number. So this would become 2x plus 3 minus, this would be 4 plus 3. Then 2x plus 3 minus, this would be just 7. And then it will become just 2x plus 3 minus 7, which will give you 2x minus 4. All right. So whenever there's a minus sign, the entire binomial that's next to it is going to be associated with that minus sign. Does that make sense? If not, it's okay. That's actually today's lesson anyway. So don't even worry about it. All right. If anything, like I said, that's today's lesson. So we'll go over it. So first things first, all right? Any more questions? Are we good? I could jump into today's lesson. All right. So first things first, right? I want to start with a little blast from the past. All right. All right. This question is a hard one. Check it out. Oops. So I got 3x squared plus 3x plus 1 plus 8x squared plus 5x plus 5, and I want to simplify it. Tell me how to do this. Or you could tell me the answer, whatever. I don't know. Right. Go ahead.
uh, you're gonna be buying light.
Right.
So everything you start with things that are expensive by using your you know, operation plan, operation, and you start with exponents, which is next to numbers.
Mm-hmm.
And the x, we start dividing out what the roots are, the x squared, getting combined with 8x squared, 3x, and 5x getting combined on 1.
Okay.
And by combine the
Okay. So combine them. Tell me what the answer is. Remember, combining like terms is like a $50 way of saying add. All right. So tell me what the answer is going to be. Anybody? You want to say it? 11x squared. Good. And then plus 8x. Very good. That's the 3x plus the 5x. Plus what? 6. Okay. And that's it. That's the answer. All right. So the terms that have x squared like on them or in them, whatever, right? You're just gonna add the coefficients. Boom, you get 11x squared. The terms that have just x to the 1 power, just x, right? You're gonna add their coefficients, and then that's how you get the 8x, 3x plus 5x. And then you just add the numbers by themselves. 1 plus 5, 6. Questions on this, anybody? Yeah. And then just go in decreasing order after that. 3 squared plus 8x squared is 11x squared. That's how. And then 3x plus 5x is 8x. So which terms have x squared on it? Right. So those two terms, right? These are what I'm adding together. Now the 3x, right, got added with the 5x, right? And then the numbers, they got added by themselves, right? Hmm? That adds to the square? Like you mean like when you multiply two squares together? That's tomorrow's lesson. Mhm. Like nice way of thinking. Yeah. All right. This is your question now, Sasha. Tell me what to do. I'm sorry. You were still copying? I apologize. Go ahead. So tell me what to do, Sasha. I'm gonna do it in the Knicks blue for you. Mhm. Not quite. It starts with a D. Yeah. I want to not divide. Give me another D word. Distribute, right? I'm gonna distribute the negative onto both terms, right? So it's gonna be 5n plus 8. A negative times a positive 2n is negative 2n. And then a negative times a negative is so plus 1. And that's it. Now we have the question that we had above, right? You want to combine like terms. So what are the like terms here? 5n and which one? Exactly, right? So you want to combine these two. So what is 5n plus negative 2n? Exactly, positive 3n, right? And this is the hard part, right? What is 8 plus 1? There we go. So we good. That's it. Not too bad, right? Yeah, if it's a minus sign. If it's yeah. If the outside sign is minus, then you distribute. If it's a plus, you just forget about the parentheses and that's it. Yeah. Exactly. You distribute the negative first. Always to the right. Yep. Always to the right. Oh, baby. Here goes this question right here. Y'all realize that I'd be asking you the same question every class, right? Right. All right. So tell me what to do. 5 what? 5 what? Very good, very good. All right. Do it for me real quick. Sure, whatever. Addition? No addition. When they're next to each other, that means multiplication. Okay. But what am I supposed to do first, though, when you're using the order of operations? What comes first? All right, and what comes after that? All right, so which one am I going to do here? Okay, good. What is that going to be? No, 25, right? This becomes 4 times -2 times 25. All right, what's next? Okay, not +4. What's 4 times -2? Yeah, you can give me a better answer. -8, right? Exactly. So now we got -8 times 25. That should be easy, right? When you got 8 quarters, how much you got? You got 8 quarters in your pocket. How much money you have? That's it. So this is -200. All right. Light work. Good. Oh, same thing. I could have put a parentheses around the 4. It's the same thing. Mhm. It's just 4 times -2. Mhm. I could have put the X multiplication. I could have put the dot multiplication. All means the same thing. Mhm. All right. Any other questions? Are we good? All right. Let's get into today's lesson. Again, this is like really, really simple. Today's lesson is like all addition. So if y'all want, y'all could just knock out y'all homework in the meantime. All right. So, but we're not just gonna start off with addition. We gotta kind of build up to it a little bit, right? What? Yeah, just a little bit. So here's where we're starting off with, right? So the first thing we want to do is we want to determine the degree of a polynomial or polynomials, right? So we have learned that a term is a constant or the product of a constant and one or more variables. A monomial is an algebraic expression with one term, right? When it is of the form ax to the m power, where a is a constant and m is a whole number, it is called a monomial in one variable. Some examples of monomials in one variable, excuse me, are 2x, 5y, 17z, and 4y squared, for example. Monomials can also have more than one variable, such as 5abc and -4a squared b cubed c squared, right? Here's the definition of monomial again. So a monomial is an algebraic expression with one term, right? That's the key, one term. A monomial is one variable, right? In one variable is a term of the form ax to the m power, where a is a constant and m is a whole number. So when you hear monomial, that's one. Remember that, all right? A monomial or two or more monomials combined by addition or subtraction is a polynomial, right? So some polynomials have special names based on the number of terms. A monomial is a polynomial with exactly one term. A binomial has exactly two terms, and a trinomial has exactly three terms, right? And then there's no special names for polynomials with more than three terms, so we just say like polynomial. All right. Questions on this? Just building some vocabulary before we get deeper. All right. So everybody's good on polynomial, monomial, binomial, and trinomial? You good? I ain't gonna lie, I don't feel like y'all good. So here's a table of definitions with them. All right. So here you go. Polynomials. All right. Whoops. Clicked the wrong thing. There we go. So polynomial is a monomial or two or more algebraic terms combined by addition or subtraction. That's a polynomial. A monomial is a polynomial with exactly one term. It's called a monomial. Binomial is a polynomial with exactly two terms, and it's called a binomial. Trinomial is a polynomial with exactly three terms, and it's called a trinomial. All right. Take a picture, write it down. Just for clarity, here are some examples of polynomials, right? So let's say you have y plus 1. That's a polynomial, right? 4a squared minus 7ab plus 2b squared, polynomial. I don't even want to read this, but that's a polynomial. Just take my word for it, right? Monomials, only one term, right? And they're combined together by multiplication. So you have like 14 by itself, a whole number. Boom. That's a monomial. 8y squared. Boom. That's a monomial, right? There's no additional subtraction here. It's just one term all combined together, multiplication. Negative 9, x to the third, y to the fifth, monomial. Negative 13, a to the third, b to the second, c, monomial, right? When we talk about a binomial now, right? Binomial, now we have two terms, right? That are connected together by addition or subtraction, right? So like a plus 7b, right? They're different, so they can't be combined, but they're connected by addition or subtraction. 4x squared minus y squared, boom, right? That's a binomial. You got two terms that connected by subtraction. Y squared minus 16 is another one. 3p to the third power q minus 9p squared q. Binomial. Trinomial, three terms. For example, you have x squared minus 7x plus 12, 9m squared plus 2mn minus 8n squared, 6k to the fourth power minus k to the third plus 8k, z to the fourth power plus 3z minus 1. Notice that they have one, two, three terms all connected by addition or subtraction. That's a trinomial. Questions on this, anybody? Go ahead. Hmm? I'm sorry.
Say they don't have variables, like 1 plus 2, isn't that a binomial?
Nah, that's a whole number. Yeah. So if you notice here, right, there are no like terms in the nomials. We combined the like terms already. This is what's left. So that's the monomial, the binomial, the trinomial. So what's left over after you combine the like terms. Mm. All right. So notice that every monomial, binomial, and trinomial is also a polynomial. They are just special members of the family of polynomials, and so they have special names. We use the words monomial, binomial, and trinomial when referring to these special polynomials and just call all the rest polynomials. All right, new concept now. The degree of a polynomial and the degree of its terms are determined by the exponents of the variable, right? So a monomial that has no variable, just a constant, right, is a special case where the degree of the constant is zero. So for example, if I give you the number 45 and I ask you, right, what is the degree of that polynomial? You're going to tell me what number?
Zero.
Zero, right? Because there's no variable next to it. All right.
You know the difference.
You can't tell the difference between a whole number and a number with a variable? What?
Um,
It's the addition and subtraction that's the difference, right? So monomial is just by itself, like these, right? Binomial is two terms being added or subtracted, right? By two. Trinomial is three terms being added or subtracted, right? That's the difference. Mhm. All right. Just to make me feel good, I like to repeat myself. So one more time. All right. So the degree of a polynomial, right? The degree of a term is the sum of the exponents of its variables, right? Let me say that again. The degree of a term is the sum of the exponents of its variables. The degree of a constant is zero, right? The degree of a polynomial is the highest degree of all its terms, right? So we got to remember that. There's questions on your homework about this in particular. All right, let's dig a little deep now. All right. So let's see how this works by looking at several polynomials. We'll take it step by step, starting with monomials and then progressing to polynomials with more terms. All right. So let's start by looking at a monomial. The monomial 8ab squared has two variables, a and b. To find the degree, we need to find the sum of the exponents. Sum is a really fancy way of saying add the exponents, right? Add those little small numbers up top, right? The variable a doesn't have an exponent written, but remember that means that the exponent is 1, right? The exponent of b is 2. The sum of the exponents, 1 plus 2, is 3. So the degree of that polynomial is 3, right? This one right here, 8ab squared, right? So just to recap, right? You have 8ab squared. The exponent on the a is 1. The exponent on the b is 2. You add them together, you get 3. That is a degree of this monomial, 3. All right? Questions on this, or we feel like we get that? Go ahead. What do you mean? My notes. No, my notes. Yeah. But I am recording it and I'm gonna send it to you. Yeah. It'll be on YouTube. Hopefully tonight, if not tomorrow. Probably tomorrow. All right. All right. Anyway, so here are some examples, right? Let's say we have a whole number like 14. The degree of that polynomial is 0. That's a constant, right? 8ab squared, right? A is 1, b is 2, 1 plus 2 is 3. Boom. Let's look at the negative 9x cubed times y to the fifth power, right? Let's add those exponents. 3 plus 5, that's 8. That's the degree of this polynomial, 8. Let's say we have negative 13a. The power on the a is 1, so the degree of that polynomial is 1. Make sense? Good. All right. Let's talk about a binomial, right? So the degree of each term is going to be given there, right? But when I say I want to know what is the degree of the polynomial, right? I want to know what is the highest degree. I'm not interested in all of them, right? I'm not interested in all the terms. I want to know what the highest degree term is, right? So for example, in this binomial, I have h plus 7, right? H has power 1, 7, is 0. The degree of this polynomial for me is 1, right? Because h has the higher degree, right? Let's look at the 7b squared minus 3b, right? The b squared is 2, the b to the first power is 1. So this is a degree of polynomial 2. Wait, this is a polynomial with degrees, with 2 degrees. Yeah. let's say I have x squared times y squared minus 25, right? The x squared, y squared is 4. The 25 constant, that's just 0. So this is a polynomial with degree 4, right? Last but not least, we have 4n cubed minus 8n squared, right? So for the n cubed, that has degree 3. For the n squared, that's degree 2. So I take the highest power. So this is a polynomial of degree 3. Make sense? All right. I literally do the same exact thing for the trinomials. But with the trinomials, I have 3 terms. That's the difference. Go ahead. Yeah.
And
Okay, go ahead.
with the previous one, it said, three, the following, for the x to the power, y to the power two, and five is four. And the other one is four, n to the power three, minus e to the power, n to the power of two,
Go ahead.
and that is three.
Right.
Why is the previous four instead of two?
Because that's x squared times y squared. So you add the exponents. Yeah. Just like how, remember when we had the 8ab, we added the a and the b powers, 1 plus 2, 3. So this is x squared, y squared. So 2 and 2 is 4.
And it was separated
By the subtraction. That's the issue. Yeah, yeah. If it was multiplication, it's a different conversation. You know? Yeah. You're welcome. You're welcome. So trinomials, I'm literally doing the exact same thing that I just did with the binomials, except now I have 3 terms, right? So I'm just interested in the term that has the highest power. I want to know what that is, right? So for example, the first term, the first polynomial, excuse me, right? In its first term, we have x squared. That's to the second degree. So this is a polynomial of degree 2, right? Same with the third. Even though the third, all 3 terms have degree 2, right? I still just want the highest term. So either one matters. It's just 2, right? The next term is 6. Look at this one. I have 6m to the fourth minus m to the third n squared plus 8m n to the fifth power. Our first term is 4, our second term is 5, and our last term is 6. So because the last term is 6, this is a polynomial of degree 6, right? And then you get the idea for the last one. Questions on this? Good? All right, let's say it was a polynomial, right? Let me give y'all that real quick. Got to build y'all up. Got to build y'all up. All right. So we have a polynomial, let's say y minus 1, right? The degree of that term is 1. So this is a polynomial of degree 1. I feel like you guys get the idea already. I'm just beating a dead horse, right? A polynomial has multiple terms. The term that has the highest power degree, that's going to be the degree of the polynomial, right? All right, so working with polynomials is easier when you list the terms in descending order of degrees. When a polynomial is written this way, it is said to be in standard form of a polynomial. Get in the habit of writing the term with the highest degree first, right? So you notice how whenever I write my answers and stuff, I go x squared, then just x, then whole number at the end. That's what they mean by standard form. That's the descending order. All right. Let's look at these real quick. This is an example. So in this example, it says determine whether each polynomial is a monomial, binomial, trinomial, or just a random polynomial. Then find the degree of the polynomial. I'll give y'all a few minutes to try that. Maybe like 2. We good? All right, let's take a look. I'm gonna help y'all out by writing this out. So this is for A, right? This is 7y squared minus 5y plus 3. My first question, what is this? Is this a monomial, binomial, trinomial, or polynomial? Which one? Trinomial, right? How'd you know it was a trinomial? Three terms, right? There we go. So it's a trinomial. All right. Now, what is the degree of this polynomial? Right? Degree two. All right. How'd you know it was two though? All right. You have the y squared, right? Let me do B real quick. So this is negative 2a to the fourth power, b to the second power, right? So what is this? Is this a monomial, binomial, trinomial, or polynomial? Don't say polynomial. What is that? Go ahead. Monomial, right? Yeah, man. Monomial, right? So what is the degree of this monomial? Hmm? 6. Very good. Let's jump to another one. I'm going to try C, right? So I have 3x to the fifth minus 4x cubed minus 6x squared. Oh, crap. Bear with me 1 second. Plus x minus 8. What is this? Is this a monomial, binomial, trinomial, polynomial? What is this? What do we think? What you think, Kay? Wait, which one? Mm-mm. So count how many terms we have. Mm-mm. So remember, trinomial, 3. Or how many terms do we have? So count them. Look. 1, 2, 3, 4, 5. Right? So what is that? Is that a monomial, binomial, trinomial, or polynomial? Polynomial, right? Because I don't have no name for anything higher than 3, right? Now, what's the degree of this polynomial? Not 10. Remember, I just want the highest degree. 5. That's it. That's the answer. That's it.
I think this is the last one.
So 4 plus 2. Yeah. There's nothing to add here. So the 4 and the 2, they're combined by multiplication because it's a to the fourth times b to the second. But anytime you have a subtraction or addition in between it, that breaks it. So it's just the one term by itself. All right. All right. Give me 1 second. So I'm looking at D now, right? So for D, I have 2y minus 8xy cubed, right? What is this? Oh, my fault. Let me get the words for you. Right? Is this monomial, binomial, trinomial, or another or polynomial? Which one is this? I'm looking at D, the pink one. Binomial, right? Very good, right? So binomial. And then what degree is this binomial? Not 3. Give me a better answer. What is it? 4, right? Because even though X don't have a power on it, there's a imaginary 1 right there. So 1 plus 3, 4. All right. I think I got one more. All right. So I got E. Trying to avoid black. Let's go green. BCC. All right. So I got 15, right? What is this? Hmm. The Y has 3. So it's the 3 plus the 1, which makes 4. The highest, just the highest. Yeah, 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 yeah. So 15, what is this? Monomial, binomial, trinomial, or polynomial? Don't say polynomial. Monomial, right? Now, what is the degree of this monomial? What's the degree? What is it? I didn't hear you. I'm sorry. It's a number. What is it? Not 5, not 3. 0. Very good. Right? No exponent. Degree is 0. Questions on this? Anybody? This makes sense? Y'all could do it in the homework, no problem. Hmm? Yeah. In another kind of way, it will be. You'll see. Yeah. Any questions? All right. Y'all feel like y'all understand it, or y'all need to see another one? Another one? All right. Give y'all a few minutes to knock this out. All right. All right. So remember, I want to know, is this a monomial, binomial, trinomial, a polynomial, and then I want to know the degree of each polynomial. Yeah, I have a few questions about this on your homework tonight. Not much, but just a couple. Tutoring is available tomorrow in case anybody wants to go. I will be there from 12 to 6 in case y'all want to come through and do some homework. No test this week. Mhm. If y'all come early, you could go to Low Hall, get that free meal for today, for the day, you know. And then y'all can go to the pantry and get y'all groceries and then go through the tutoring. I recommend going to pantry like kind of late, like 5 p.m. ish, or in that 5 o'clock hour. That way to like maximize the whole like time on campus until the end of class kind of thing. Also, when I be telling y'all about pantry and stuff, I don't know if I'm like expressing it in my voice, like how much groceries you're gonna get. Like, I don't know if y'all thinking that's gonna be like a box of cereal and that's it. Like if y'all see people on campus, they have carts, like it's mad groceries. So like bring bags, you know. If you have a car, even better. Mhm.
Yeah, I would tell you to the part.
Right? The cart.
I
Need
did
that.
that, I wasn't in this state.
Yeah.
They give you off.
Yes. Yes. Super heavy. Yeah.
Can you come in here like on that?
Yes. I have to think about that answer. Um, I'm almost tempted to say as long as you're a student somewhere, you know? So let's say for example, right, you are a student at Lehman, right? But BCC is just across the street from your house. So obviously you want to come to pantry here instead of going to Lehman, right? So you can do things like that. Like if BCC is closer to you, you can receive your pantry stuff from here because you're a student at Lehman, you know? And vice versa. Let's say you live in Queens and um Queens Community College is closer to you or LaGuardia is closer to you. You can actually get your pantry from there through BCC. Like basically the same people that I told you to sign up with, they will communicate with them and say, hey, listen, like this person is our student, but they live closer to you, so you give them the pantry over there, so it's easier for them to take it home. Yeah. No, there's also Hostos and then there's Lehman. Yeah. When you graduate from here, you go to Lehman. That's a senior college. Yeah, yeah, yeah. It's not bad. You'll get there, don't worry. Lehman's a good school. I mean, that's the Mecca, you know. Uh, you good? All right. What y'all got for A? Is that a monomial, binomial, trinomial, polynomial? What is that? Monomial, good. Now, what's the degree of this monomial? What is it? Zero. Good. All right. So, what is B? Trinomial? Mm-mm. Give me a better answer. Polynomial, right? It's poly because I have four terms, right? So one, two, three, four. What is the degree of this polynomial? Two. Give me a better answer. Three, right? Because we have the y cubed right here, right? How about C? What is that? Is that a monomial, binomial, trinomial, polynomial? Which one? Trinomial. Very good, right? Now, what is the degree of that trinomial? Four. Good. All right. How about D? Is that a monomial, binomial, trinomial, polynomial? Which one? Binomial. Very good. Now, what's the highest degree of that? Like, what is a degree? So I heard two and I agree. Okay. What about E? A little bit harder. What is that? What? Together, right? So you see this term right here? That's the highest degree term. So that the Y has power 3 and the X is power 1. 3 plus 1, 4. Yeah. Mhm. So what about E? What's the what is this? Monomial, binomial, trinomial, polynomial. Go ahead. Yeah. Monomial, okay, good. And what's the degree? Good, 10. Questions on this? All right. Let's look at what we getting into. So we are going to add and subtract polynomials. We have learned how to simplify expressions by combining like terms. Remember, like terms must have the same variables with the same exponent. Since monomials are terms, adding and subtracting monomials is the same as combining like terms, right? If the monomials are like terms, we just combine them by adding or subtracting the coefficients. All right. Simple, simple, simple. All right. Let's try it out. For A, this is what I have. 25 y squared plus 15 y squared equals what? 40 y squared. Exactly. Right? They are like terms. They both have y squared. So I just add their coefficients, the number in front. So 25 plus 15 is 40. That's it. Let's look at B. All right. So for B, I have 16. It's going to be hard now. PQ cubed minus negative 7 PQ cubed. All right. Sasha, this for you. What's the answer? 23 what? Very good. That's the answer. Done. Any questions on this, anybody? Go ahead. Mm-hmm. Right.
Mine gave, I get a 6, but when I rewrote it again, it's actually a problem.
I think it's positive 4, no? Yeah, yeah. Yeah, yeah. But you did this correctly, right? So you distribute the negative, making this into a positive, and then you added it. Very good. Right? So yeah, do y'all feel like y'all got that, or do y'all want to see another one? Because I'm adding and subtracting. When I get to multiplication division, then they'll change. Yeah. Y'all feel like y'all got it, or y'all want to see another one? Got it? All right, let's move on. Do, 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 do. Remember, Remember that like terms must have the same variables with the same exponents, right? So let's try this out. This is A. I have A squared plus 7B squared minus 6A squared. Combine like terms, what do I get? Somebody tell me. All right, so I heard 7B squared minus 5A squared. That's right. All right. So my A squared and my negative 6A squared, that's what I'm combining like terms on, right? 1 minus 6, negative 5A squared. And then just bring down the 7B squared. It doesn't matter the order that you put this in. Addition is associative. 1 plus 2 is the same as 2 plus 1, right? Just letting y'all know on that. Let's look at B. I have U squared V plus 5U squared minus 3V squared, right? Let's combine like terms and tell me what the answer is. Go ahead.
Here, 6U squared negative 2B cubed.
Mm-mm. Are there? Hmm? Okay, so what's the answer? My man, that's what I'm talking about right there. Yeah, that's the answer right there. All right. Because all those terms are different. They're not like terms. All right. Questions on this?
They're gonna be like out in the.
Yeah. Also on your homework, so. Hmm?
Negative 6. So it's-
Because they both have A squared, so that's why they could be combined. They have to have the same variables in order to be combined. All right. So do y'all get it or y'all want to try another one? One more? All right. Whoops. My fault. So go ahead, try those. Okie dokie. So, a little pixelated. 8y squared plus 3z squared minus 3y squared. Okay, what's the answer? Squared plus 3z squared. Good. Well done. All right. Da, 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 da. What else was I supposed to do? Is that it? Yeah. All right, let's look at B. Let's go with orange. So I have m squared n squared minus 8m squared plus 4n squared. What's the answer? Very good. And that's it. Questions on this? Anybody? Good. All right. So we can think of adding and subtracting polynomials as just adding and subtracting a series of monomials. Look for the like terms, those with the same variables and the same exponent. The commutative property allows us to rearrange the terms to put like terms together, right? Let me show you what I mean by that. So look at this question. It says find the sum, right? You see, when it says sum, you can just drop the parentheses and combine like terms. That's it. But let me show you what the commutative property is saying, right? It's saying that I'm allowed to reorder this, right? I could put the like terms together, right? I could put the like terms together. So the 7y squared plus the 4y squared minus the 2y minus the 8y plus the 9 minus the 7, right? And then now it's easier for me to just combine like terms, right? Do it for me real quick. What's the first one? 11y squared. What else? Minus 10y. Excellent. Okay. With plus 2, right? That'd be the hardest one at the end. 9 minus 7. All right. And that's it. Questions on this? Anybody? Is it good? All right. That's like most of your homework is just doing that. You know? Do we need to see another one or y'all get it? Good? All right. Let's move on. A little bit more tricky. Here we go. So with this, it says, be careful with the signs as you distribute while subtracting the polynomial in the next example. So check out what we got now, right? We want to find the difference of these two polynomials, right? So I got 9w squared minus 7w plus 5 minus 2w squared minus 4, right? So what should I do first? What you want to do, you want to take your negative and distribute it to each term to the right. So this becomes what? 9w squared minus 7w plus 5 minus 2w squared. A negative times a negative is a positive plus 4, right? And then just combine like terms. If you want, you could rearrange it like I did in the previous question and combine like terms or just combine it naturally. Tell me what the answer is real quick. It's a W, by the way, in case it doesn't look like that. Uh-huh. Minus 7W. Very good. Plus 9. Excellent. And that's it. Any questions on this? Anybody? So when I'm subtracting, distribute the negative onto the term to the right, and then just combine like terms, and that's it. We good? You want to see another one, or are you good? Huh? One more? All right. All right, try this out. Oh, hold on, I messed up. 1 second. All right, go ahead. Try that out. By the way, regarding tutoring tomorrow, if you guys can't physically make it here like for a class like that, y'all can also do tutoring online. You know? Just click the link, make the appointment, and then they'll email you the link for tutoring online. You know? Oh, this one, CPH 303. You know the building with the arch? I don't know if you know that. Like you're going towards Colston, that there's a building with an arch over there, right? That's CPH. Yeah. On the third floor, room 303. Yeah. It's called Carl Panach Hall. Yeah, so we just say CPH, Carl Panach Hall. I don't know how to spell that, I'll be honest. I can't promise that there'll be snacks there. Last week when I was there, they had Rice Krispie treats. For what? No, no, no. That's for tutoring. Yeah, groceries is Nichols Hall. Nichols. You know the one with the silver ramp in front of it? That's Nichols Hall. Right across the where the track is. Yeah. The ASAP building. That same on that same first floor, just make a left. Yeah. Nichols Hall. Yeah. If you know the building for ASAP, it's that building on the first floor. Then just make a left. And then for the free meal, that's in Lowell Hall. So that's the admissions building. Or if you know where the veterans office is, it's that building. Or if you know where disability services, it's that building. Or if you know where public safety hangs out, it's that building. Mm. All right, tell me what to do. What do you think? Distribute the negative. Very good. So what do I have now? Very good. And then now let's combine like terms. What's the answer? Very good. Yeah. And then what else? Very good. And then -5. Very good. You could just leave it out. Yeah. No, just like don't even write it. Yeah. So like 0x² is just 0, so you don't need to write it. Questions on this, anybody? Okay. The bulk of your homework is doing this stuff. Here, try this. A little bit harder. Take the 10 instead of you get to. The rest of what we're doing, you pretty much know how to do it. Okay. Gotcha. No worries. Let's do this. Do this. Shit, you. All right, so what we got? Good. That's 5v squared. Very good. Any questions on this? Anybody? So when we're adding polynomials, just drop the parentheses, combine like terms. That's all it is. All right. So we feel good about this topic? That's it. Yeah. All right, so let's change gears a little bit. Y'all kind of know how to do this already, but just humor me for a second with the new vocabulary. All right. All right, so we're gonna evaluate a polynomial function for a given value, right? So a polynomial function is a function defined as a polynomial. For example, f of x is equal to x squared plus 5x plus 6, and g of x is equal to 3x minus 4. These are polynomial functions because x squared plus 5x plus 6 and 3x minus 4 are polynomials. All right. So a polynomial function is a function whose range values are defined by a polynomial. All right. So blah, blah, blah. In graphs and functions, we were introduced to functions. We learned that evaluating a function means to find the value of f of x for a given value of x. To evaluate a polynomial function, we will substitute the given value for the variable and then and then simplify using the order of operations. Literally the same thing that we did before. All right. Just humor me for a second. So I have f of x is equal to 5x squared minus 8x plus 4. First question, A, right? What is f of 4? Tell me what to write. What should I write? See, very good. All right. Do the math on that for me, right? 4 squared is what? 16, right? So 5 times 16 minus 8 times 4 plus 4. What does that equal? What's 5 times 16? It's 80. Okay. And then minus was 8 times 4. All right. Give me something better. Huh? Yeah. What is it? 32. There we go. Plus 4. Oh, no, no. He said 52. Yeah. I got you. I got you. That's actually the amount of points we're gonna win by tonight, 52. So that's why, the confusion. I got you. All right, what's 80 minus 32? 40 what? What'd you say? You said 48? Okay, I'm sorry. My fault. My hearing not so good right now. All right. 48 plus 4 is 52, right? So there we go. That's our answer. Questions on this? We get it, right? Just plug it in. Let me switch it up. So for part B, I want to know what is f of -2. Tell me what to write. Mm-hmm. Very good. All right. And then go through it for me. This becomes what? 5 times 4 minus 8 times -2 plus 4. And then what's 5 times 4? So 20. All right. -8 times -2 is what? Positive 16. Very good. Plus 4. And what's that? 16 and 4 is 20. So I think 40, right? Something like that. Not too bad. What do I want to do? Let's go pink. All right. So let's talk about C. All right. So in C, I want to know what is f of 0. All right. So what you gonna write? Very good. Minus. Very good. So we're good. So what's the answer? Plus 4. Very good, right? 0 minus 0 plus 4 is equal to 4. All right. Questions on this, anybody? All right. Y'all need to see another one or y'all feel good? Y'all feel good? All right, that's it for today. Y'all can start your homework. All right. If you finished your homework, just sign the attendance before you leave. That's all I ask. All right. May I take this down? Can I take this down? Okay. Okay, okay. Finish everything? Yeah. All right, no problem. No problem. Oh yeah, definitely. Yeah, you too. Yo, back in the day though, man, like I'll be watching the games and then like every time they put on commercial, I'll be doing like homework. Mhm.
Yeah, because like I bought the ESPN package, but it don't come on the ESPN package.
No?
No, like
No, it's on ABC 7.
exactly.
Yeah.
That's why I'm like,
Yeah.
that's why I'm about to get NBA TV.
Did you get that dual package, the one with Hulu and
Yeah.
Disney?
And Disney.
Yeah. Now I want so I'm gonna tell you what the problem is now. Right? So I got HBO on my TV. So I have HBO Max, right? But that dual thing is fire. The one with the HBO,
And
the
Disney.
Hulu, and the Disney.
I be watching now. Like look, yeah, they got the Avatar.
Yeah, yeah,
You know,
yeah.
not the last Airbender.
All 3 of them.
Not
The blue people. Yeah, they got all 3.
I only seen 2.
Nah, there's 3 of them. Yeah, there's a 4th one that's supposed to be coming out.
Bluey?
Oh, Loki.
Yeah.
Loki was fire. That TV show.
I didn't watch it because like it wasn't my thing.
Really?
It wasn't really my thing.
You know what wasn't my thing was fucking Spider-Man. Like
What?
fucking Amazing Spider-Man. That wasn't my thing.
For real?
Yeah. Sure. Yeah.
I love that show.
Yeah. No, the movie.
Yeah, I love that movie.
You love that movie?
I love
don't
it.
know.
I think
'Cause-
Homecoming was the best one though.
Yeah, that was good. Let me tell you what happened though, right? So thank you. So I saw Spider-Man with Tobey Maguire, right? All right. So for me, that's my Spider-Man. And when they came out with Amazing Spider-Man, I'm like, why they remaking Spider-Man? So I'm offended now, right?
Yeah.
I didn't know they was gonna tie all this thing together and then like put it into like a Marvel. I didn't know that it was gonna go that direction.
Yeah.
But
They
it's
had like 3. They have like 4 Spider-Mans.
yeah, well no 3 of them.
Well, the
There's-
black one,
there's-
the black
Oh yeah,
animated one.
yeah. He's supposed to be in the what you call it, the new Avenger movie.
Really?
Yeah.
They coming out with another one?
Yeah.
I'm just pissed that
It
Tony
was
Stark
Spidey
died.
verse. CPH. You know that building with the arch in front of it? Or if you know where Colston is in the back. So right before you get to Colston, if you just like look to the left, you'll see that arch building. Yeah, on the third floor, room 303. Yeah. All right, I see you. You out? I see you, man. Good. Not bad. So, not bad. You should have a real nice voice.
Yeah,
What's a major?
radiology. But she don't be in the hospital.
Mm, okay.
That's bad.
Radiologist is one.
I mean, yeah,
You know what's funny, man? Like,
she you could tell like she's sweet. You could tell. That's what I like about
my time on this campus, man. This gonna sound crazy, but there's a correlation between beauty and what's the word? Let's say graduation, right? You see when girls start off in school, right? They the most prettiest things you ever see. Every day is like a fashion show. You see when they're like that last year, that last month before graduation, I mean the last semester before graduation, you know,
her.
don't get me wrong. Graduation day, they are fly as fuck, you know.
Yeah.
But like, it's like as they get closer to graduation, they start putting their schoolwork more, you know, and then can you see it, you know. Even when you go to the 4 year school, you go to the 4 year school, right? Them chicks, it's
You think
busted
it's worth
compared
me
to
going to a 4-year school? Think so?
all the things you want to do for sure.
Yeah, I'm gonna need the money.
Yeah,
I just turned down to $30.
for real.
Yeah,
Okay. I like the truck driving thing, you
yeah.
know.
But I wouldn't be working as I'm just thinking about the workload because at least as a software engineer, I
Yeah.
can easily pivot. You know what I mean? Just look at the charts real quick, go back to
Why not?
work.
Why not just do the whole chart thing all day?
Like how?
Like major in finance or work on Wall
How
Street.
how would I work on Wall Street?
So what would
I've been
happen?
looking.
So what would happen, right? Is that you would work for kind of like the prop firm shit, right? It's this exact same thing, right? Like but you're working for like a bank, and the bank would say like, all right, here's I don't know, what's a good number?
Oh,
Maybe a standard lot. Here's 100,000 clients,
mhm.
right? So it's a big name bank. He has 100,000 clients. All of them put their money in into the bank, right? So you're gonna have access to that money that they put in. It's up to you to invest it to grow it, right? So instead of you trading with I don't know, like whatever money you have, right? Or whatever money the prop firm gave you, you might be handling like $1 billion account or something, you know? So like you gotta like, make your lot size appropriate and all that, make the right moves, and then you get the interest in it. So
Well, how would I go to school for it?
it's major finance.
Just major in
That's
finance?
literally what people do in
So,
finance.
so I can major in software and computer science and then minor in
Now,
finance,
I'm
right?
telling you to forget the computer science and finance and stuff.
Was that a lot of math?
Yeah, yeah. Both of them is a lot of math. But the thing is with the software, like you just writing code, and I'm not gonna lie, you gonna get nice at it, and then you're gonna get a good paycheck, But why learn two tricks? Why not just be a master of one?
Yeah, I was thinking about majoring in finance or e-commerce.
Yeah. Economics is different though. So, all right, let me put it to you like this, right? Like when you have like physics, for example, like say we playing pool, you hit the ball and all that, then equal opposite reaction, all that shit, all that physics stuff. Physics is a science, but the language that physics uses to explain all of that is math. Okay, right? All right. Economics is like math, right? The language that finance is using to explain all this shit is economics. Think of it like that. I'm not really saying it the right way, but
I'm gonna give it some thought.
you
Wow, I like you, Professor. I'm gonna give it some thought. I'm gonna give it some thought. I'm definitely thinking about it because it's worth it, you know?
and let me be honest, you majoring in finance doesn't mean that you won't code,
Okay.
right? Because you could make a
I heard
like an
fintech.
algorithm or something that will invest for you.
So I can do.
That's a thing
I can do
too.
computer science as my associates and then finance as my master's.
Finance is more of a master's degree.
Oh, so
Yeah.
I would need a bachelor's in finance?
No,
Oh.
to be honest with you, I don't even think there is a bachelor's in finance. There's a bachelor's in econ, you know? So here's one way you could do it, right? Let's say you really, really want to do the coding.
No, I really,
Bachelor's,
I'd rather be on the Wall Street floor.
that's what I'm saying. But like, let's say you wanted to do like algorithmic trading, right? So you're like training a computer to trade for you. So but you have to go down the computer science route for that. You could do computer science associate, computer science bachelor's, and then master's in finance. Boom, you're on Wall Street. So that's one way to do it. Another way to do it, like say you're trying to, yeah, you really can't avoid the math of finance. Like, nah, you still got to go down that math rabbit hole with finance. Because I was gonna suggest, oh, you could do econ and then pivot from econ into finance. You know, like that works also, but still, you're gonna be like deficient in the math.
Right.
Yeah. I don't know. It'll all work out. You could also major in math and then pivot into finance. That's another way to do it too. Mhm. But for sure, the easiest way to do it is the econ way. Econ into finance.
Thinking of e-commerce.
E-commerce? E-commerce is marketing. That's a different degree.
I suck at marketing.
How you know that?
Can't build an account on Instagram.
That's a type of marketing, but that's not all of marketing.
Oh.
Like marketing is deep. Like you so there's different branches
I
of
was
it.
thinking about going to Lehman to be a software marketing major,
Okay.
but I don't want to take too much. I'm not trying to take the wrong risk.
Okay.
You know what I mean? Because like I don't know how marketing major would flash out. Like you know, like I think I'll do good. I think
Yeah.
I'll do good. Like financially, I'll do good because everything's tech
Yeah.
driven now.
Marketing makes money for sure, you know, but
But if I want to sit down and use something, like learn something that I'll be able to use in the long run,
yeah.
I mean, I'll always be able to go back to school and be a software engineering major. So a social media major. I'll be able always be able to
There
do
is a
that.
social media major. My cousin did it.
Is it worth
it's
it?
called ad PR, advertising and public relations.
Is it worth it though?
He makes money. Like keep it 100 with you. He does make money.
You can think if you had a YouTube channel.
Yeah.
Yeah,
Yeah.
because like I have a business where I need marketing, but it's like I also need money, and it's like I don't mind. I was already thinking about the being behind the computer and trading at the same time, my own account.
Dope.
You could do that
Like,
too.
That's dope.
that's what I was really thinking about doing because like I'll be able to learn a skill. I could build apps. Any app that I want. I got a couple of apps, a couple of inventions that I
Yo,
jotted down in my
AI
notes.
don't fuck that up for you, man. I ain't gonna lie.
Yeah. That's why I'm like, do I even want to be a software engineer? Because it's like,
I'll tell you something that happened to me earlier this year. So they sent out this email to everybody, right? I'm supposed to send it to y'all students, let y'all see that shit, right? But then I ended up applying to it myself, right? So they had an AI workshop. All right, cool. I wanted to learn about it, right? I'm not trying to do anything crazy. No, hold on a second. Kel, you still good with this, man? I want to start downloading this. Yeah.